All right. So yesterday we were doing few exercises. So let me try to recap those exercises and then we'll move ahead. So first exercise that was given was essentially to, to see if we can find the multiples of 3 and 5 below a given input, right? So let me try to do that and then we'll see the others. So let me call this exercise June 5th. Okay, so the first exercise that we had seen was to find the sum of all the multiples of 3 and 5. Three or five. It was not 3 and 5, 3 or 5 below a given input, right? Below a given input. Right. So and the other condition that we had was if the given input is below 0. Below or negative, or it is negative, then it should return 0. Right. So this is what we had. So I'm using the Visual Studio Code. If this is not yet set up on your machines, I would request you to use the spider ID. Okay. So I'll write the main method. Okay, let me try to run the main method and then let's call our function. So till then I'll write the pass here and then let's call our function. So let's call our function div 3r of 5. All right, and then the input that it takes is a number. And then I try to, sorry. All right, so that is what it is. So, okay. So then, so I call this condition if number is less than 0. This was one of the conditions in this particular exercise. And then I return a 0, right? So if this is the condition, then it should return 0. Or what we'll do is we'll try to write a list comprehension such that the list comprehension is passed to the sum function. Okay, we pass it to sum. So I'll have this later, but let's try to get our list comprehension. So let me try to write it here and then put it in the return statement and pass it to num. Pass it to sum. Yeah. So first thing is I'll say list comprehension num, and then for num in range of number. So we'll be passing this particular variable to the range function, and whatever it is, it will take the number less than whatever is being passed, right? 1 less than this particular number. So it will be number minus 1. The sequence of numbers would be generated, right? We have already seen range of x will start from 0 and end at x minus 1, right? That is what range of x would give us as the output. And now, so num is being returned. We are trying to iterate over, and the condition is this: if num modulo of 3 is 0 or num modulo of 5 is 0. Right? This is what would be our condition. And that is what I have put. And this is saying number is not recognized. So what we'll do is we'll take this list comprehension. Right? This is our list comprehension. Right? For num in range of number, this is what would be passed. And then we'll put this into the sum function. Right? We pass this to the sum function. Now, because we are getting a list, sum of list will be nothing but sum of elements of those values in the list, right? That is what we need. We need the sum of values. So let's say we had something like this. Before I call that function, let me try to explain what we are trying to do. So we have 2, 3, 4, 5, 6, okay? So the sum is 11 plus 4, 15, 15 plus 5 is 20. So if I do this and then do a sum of this, right? This will give us a sum of all the numbers that are there in this list, right? So that is what we are expecting. So let me try to run this quickly, and then we see the output is 20. So that is what we are trying to do here. We want to find the sum of all those numbers that are divisible by 3 or divisible by 5, and we want to return it. That is what we are trying to do here. So that is what I have done here. So instead of calling that sum, I'll call this particular function in print so that we get the value out of it. And then I pass some number, let's say 20. All the numbers that are there less than 20, we want the sum of all the numbers divisible by 3 and 4, 3 or 5. Okay, so sum of numbers less than 20. And then this is our, and the rest of the thing is basically the sum, right? So I call this run function here. So this is 78, right? So that is what we get as the sum. Okay, so that is what we have done. This is the first exercise. So how do we check for the cases is, let's say I write some assert statement. Assert statement is checking whether what we are doing is correct or not. So I call this function, I pass 10 to it, and then say equals to 23. It's just like a test case, okay? So if this was true, then nothing would be raised as an error. If this was false, it will raise an error, right? So let's try to see if when we run this, right, it gives us 23 or not, right? So let me try to run this quickly. So nothing happened, right? So what it means that is this statement ran correctly. And what this assert does is stating that this is exactly true. Let's say I change this from 23 to 21. Instead of 23, I change this to 21 and run this again. Okay, let's see what's the output. And you see the error that is being thrown, right? It says it is called as an assertion error. And where is the assertion error? At this particular line number 15, there is an assertion error. And what does it say? That the call to the function div3r5, when the input 10 is passed, it returns 23. But what we are making it equal to is 21, or the checking value is 21, right? We are trying to see if it is equal to 21, which is not the case. And hence, the assertion is false. It raises an assertion error, right? So whenever we want to test our code with something, right? Probably print statement will give us the right value if you know this is the output that we are expecting. 78 is what we are expecting. But then if we want to really test it and see the code is perfect, right? So I can write these assert statements. Let me change this to 23 and then call the another assert statement. We can have multiples of them, and then I write 3 or 5 and then pass 20, then make it equal to 78, right? So now if we run this program and see the output, right, there is no error. Sum of numbers less than, this is the print statement, and then the assertions are not throwing any error, right? So when this happens, now what it means is that these two statements are working perfectly fine with the expected output. Whatever is passed and whatever is expected are correct. Whatever we got as the output and whatever is expected is correct, and the assertion is fine. It is correct. So that is what assert statements help us do. It is like checking for minimal test cases for a function that we write. This is kind of a test case. Okay, so we are testing our code. Let's try to do this. Assert and see if this also works. So I call assert div3 or 5, and then I pass, let's say, -5. This should return 0, but I test it for 1. Okay, this should return 0. I test it for 1 so that we know they should throw an error. The last assert statement that we have should throw an error. So let me try to run this. Right now, this gives us an error, right? What we are trying to do here is that we are trying to, is not defined. Where does it say? This was there, right? This is what we did. And let me try to rerun this program once again. Looks like it says this function is not available, but then we checked it. Let me try to see now. Yeah. So probably there was some space or something, right? Yeah. Okay. Now we get the assertion error, right? Indicating that the line that we are testing here is probably on line 17, right? At line 17 is what the error has occurred at this particular line. That is what it says. So when this particular file was executed, right, and the error is occurring in this file, that is also what the error says, right? So we got this sum of less than 20 traceback, and the traceback says this is the file where the error has occurred. It is at line number 17. And what is the error? It says an assertion error. And what is the statement where the error occurred? This is the line, or this is the statement where the error occurred. So you can use these assert statements and see whether this is correct or not, right? So this is one way of checking it. And let's say I change this to 0. This is our original test case. Then probably if this was returning 0 and this is also 0, this should be fine and our code should not give us an assertion error. Right now, nothing happens, right? Everything is fine. And it says exited with code is equals to 0. So whatever Visual Studio Code, or if you're running in Jupyter or in probably in the Spider IDE, then you should not see any errors in the output. Fine. So this is what we have done. Hope this is clear. This is our first exercise, right? This is what we have done. We want to try to see if the errors are correct or not. Sorry, we want to see whether the sum that we obtain for multiples of 3 and 5 is the correct that we are checking in the main method. All right. Any questions on this? What we have done with respect to assertions and also the function for the first exercise? All right, if there are no questions, then we will do this. We'll go to the second exercise, all right? So the second exercise is write a camel case or we want to have if there is a camel case, then, or let me try to do this. If a camel case word is present, then add space in between, right? That is what we want to do for the second exercise, right? So I call this as def, and then I call this function as br camel case. Okay, fine. What is a camel case, right? So I pass something to this, and then I say pass. So essentially a camel case is something we have of the type something like this. So let's say I have hello, and then there is an uppercase letter for the second word. This is a camel case, right? Right, so we have hello world, and this is a camel case. So the second word, word is capitalized for the first letter, or the second word begins with a capitalized letter. This is what is a camel case. So if we have something like this, hello world, and what we expect the function to do is we need to get something like this, hello world. Okay, this is what we expect. So similarly, if we have a word like camel case, then we expect the output to be this way. We have camel and case. The words are separated. This is what we want to do. Okay, that is what we expect the output to be written as. So how do we write this, right? Again, we'll try to use a simple list comprehension, right? Before we try to return it in this function, Let's try to write a simple list comprehension for this. So I have something like this. I specify space plus I, but even before that, we want to iterate over the string, right? We want to iterate over the string. So I'll iterate over the string for I in S. The first thing that we want to do is iterate over the string. And it should return something. That is what we'll try to write it in this left-hand side. This is what would be the element for every iteration, the element that would be returned in the list, right? This is what we get, right? This is where we want to write our logic. So space plus I, if I dot is upper, right? Else it should return I. What does this mean? Whenever we are iterating over this particular word like this, hello world, let's say we are iterating over the word like this, right? If it is a lowercase, it should return the lowercase letter, right? That is what should happen. The moment we encounter a uppercase letter, it should be appended with this particular empty space and then followed by the word or the letter, right? That is what should happen. That is the condition that we have written here. If I dot is upper, then it should return this particular value, else it should return I. And this is the return value with the condition that we have written. And what is happening for I in S? We are iterating over S. Whatever the string that we are passing, we are iterating. And here we expect that camel case is working. We are not checking for the other conditions. We expect the input to be in camel case, the entire word to be in camel case, right? That is what we are trying to do. So all that we have to do is take this particular list expression, list comprehension expression, and then I remove this pass. Instead of pass, I write return followed by this constructed list, right? We are trying to return the list. Right? Or if you want to write multiple steps here, we can say L1 is equals to this particular operation that we do, and then write L1. This is also something that we can do, right? Instead, we want to eliminate this and have just this particular function return and do nothing here. So I remove this function and finally we just want to return because nothing is being used with respect to what is done with this list, right? We are not using it again in this function. So I finally write this return statement, right? So again, how do we kind of check this? So let me comment out these first few lines that we have done for the first exercise, right? I comment these out and let me call the assert statement on this particular function, right? So I say assert, oh, sorry, I think the cursor is not at the right place. Let me try to click it here. So assert, and then we have the function that we have written for generating that camel case. So I write hello world. Okay, this is what I write. Equals to what should be the output that we should get is what I will write here. Okay, so I compare this like this. So whatever the input is being passed is passed to this function and it is equated to the expected output, right? That is what I'm trying to write here. Similarly, assert via camel case and then what we want as the input. So I say camel case. Okay, that is what I pass as the input and then I equate it to camel case. Okay, so this is what I want to get the output as. So if we run the program now, the input is passed and the return statement should be what we are expecting. Then the assert statement should not throw any error. Fine, so let's try to run this. So looks like there is some error. The reason is we are not checking this as a function. So let me call this as a function now. Okay, that is the reason why we might got that error. What is this again? Camel case hello world is Something is not checked properly. Okay, yeah. This would be list, right? What we are getting the output. Okay, let me try to see what has happened. So let me try to comment this out for the first case. Let me try to print the output. Before we get something as an output, let's try to print what is being returned and then we can debug, right? Assert is going wrong, right? That is what we have seen. So let me pass this here to this particular statement. Okay, and then we see what is going wrong. So we got this output, right? Essentially, we got this output, but then the space is appended. But this is basically a list value from the list compression that we actually perform. All that we have to do is we have to join them, right? So I'll say something like this: just join them. We do not need any empty space, and then pass them within this join function. So whenever we do this, right, all the elements are joined. So we have a list of values, and then all that we want to do is join them, right? So something that we want to concatenate, we can do using the join function on the string object. The string object is a empty string. It is nothing. It is nothing. This was a space string, right? We had a space here. This one is an empty string. So the list would be converted to string value. So whenever we want to convert a list to a string, this is how we can do, right? So now let me try to run this and show the output. Now it is basically hello world. Now we can check for our assert statement. So let me try to uncomment the assert statements and see what is the output. Okay, so I uncomment this and try to run them. Right? There is no assertion error. It means that whatever is checked for or what are the expected output is for the given input is correct. Fine, that is how we will be able to check this. So any questions on this, guys? Is this clear? All right, if there are no questions, then we will move ahead. Let's try to do the next exercise as well that was given. So let's try to do that. So the next exercise that was given is we need to move the zeros. And let me try to write the problem statement. So we wanted to write a function that takes an list, right? A list and moves all the zeros to the end. And this should so this should also preserve order of the other elements, right? That is what we need to do. So what we'll try to do here is let's try to write a function again. So I call def and then move zeros. This is our function. And it should expect a list. So I call the variable as LST. That was one LST. And then I write a pass. So before we implement the logic for this. Okay. So there is no error in the file when we write pass. So what we'll try to do is we'll try to write a simple function for this. And this can be done in multiple ways. I want you guys to explore the list comprehension way of doing this probably when you get time. But then the most straightforward way of doing is to check if it is 0, remove that and append it. So let's say we have something like this. Let's say if the input is we have 1, 2, 0, 1. And then 1, 0, something of this kind. We want the output for this to be something like this, right? We want the output as 1, 2, 1, 1, 0, 0, 0. There are 3 zeros, right? Here, 1, 2, 3. And we should have 1, 2, 1, 1, 1. So we have 1, 2, 1, 1, 1 as our previous order, right? If zeros were removed, 1 should come here, 1 should come here, and 1 should come here. And the 0 should be placed at the end. So what we'll do is we'll remove this 0. Let's say we remove this 0, right, from here, and then append here. As and when we encounter a 0, we'll remove this 0 and then append here. So again, I'll remove this 0, then append here. So we'll iterate over this list and finally append the 0 to the end of the list. All that we have to do is this. We have to check if there is a 0, remove it from the list, and append it at the end. That is what we need to do. So when we remove, element will be lost, right? So the element will be lost. It will no longer be available with the list. So we have to append a 0 at the end. Right? That is what we'll try to do as our simple logic in this question. So I remove this pass. So first thing is for num in list. So we iterate over this list, right? And what is the condition? If we are encountering 0 and if it is equals to num, right? From the list, remove the element, which is nothing but num, right? And in this case, it will be 0. If it is 0, we have to remove 0. And I'm saying remove that element. And then append what? 0 at the end. That is what we have to do. And that is what I'm trying to do. So this 0 will be appended at the end. And what we have to do is to return this list at the end. So I say return list. Once again, what we have to do is whenever we encounter a 0, right? So if the original, okay. Whenever we encounter a 0, right? Let's say this is our 0's position originally here, right? And all that we have to do is remove this element and append at the 0. Similarly, if we had a 0 here, remove this element and append at this end. Similarly, if we had a 0, we have to remove this and append it at the end. That is what we have to do with this particular arrangement of values with 0. So what we are trying to do this is iterate over the list. If 0 is equals to num, right? Then remove that number, which is nothing but 0, and append a 0 at the end. If we remove this number, it will no longer be available in the list. That is why we are appending 0 instead of specifying it as num. Okay, that is what we are trying to do. So that is how we are checking this and we get the required output. And this could be done in multiple ways. This is one way of doing it. But if you think you would like to do this in list comprehension, you can take this as an exercise and try to do that in list comprehension as well. Already we have seen how to do that in list comprehension previously for the other two exercises. We can perform this as well. Okay. So let me try to comment this. We have checked this also. And then I call assert. And then I call this function move zeros. And then pass the values that we had written earlier. Okay. 0, 1, 0, 3, 0, 1. So what I'll do is I'll take this same list. Okay. And then modify the arrangement so that we don't miss out on the zeros. So I'll take this 0. All that we have to do is put it at the end. Right? Take this 0, put it at the end. Take this 0, put it at the end. Take this 0, put it at the end. Right? So this is the expected output. So if you have a smaller list, we can add another assert statement. So move zeros. So let's say we have something like this. 1, 0, 1, 0. Right? This is what we have. And then we can do something like this: 1, 1, 0, 0. Okay, so we got these assert statements correctly. So instead of doing like this, if I had done, let's say, okay, let me try to remove this one here and then check if the assertion error is raised, right? We are getting the assertion error. Fine, so this is the assertion error that we get when we try to do this. So let me try to move it back to the place it was. So I have one revert it back to the place it was. Okay, so that is what I'm trying to do. So is this fine, guys? Is the logic clear with respect to what we have done? We just have to move the zeros to the end. And this could be done in multiple ways. This is just one logic. So please try to explore the other options or the other ways to perform the same logic.
Hi, Jayant. I have one question.
Uh-huh.
Yeah. So, like, you said, like, we can try it in comprehension, right?
Mm-hmm.
So, can we have two statements in the comprehension starting?
Yes, so we can do that. Probably I have not covered it. So let's
Oh,
take an example. I'll do that as well. Okay, we can have it. But to answer your question, we can have it.
yeah. Because like till now, like we were seeing only one statement in comprehension,
Mm-hmm.
but in condition we have like a else if. But here there are two statements, so that's why like
Okay, when you said two statements,
like
prob
one we are removing, then we are appending, right?
right, right.
Yes. So can we
So
have two
can we have two
action
uh,
actions?
actions in the same thing? So if we have multiple statements, then probably, because uh, multiple statements we have, the readability of list comprehension will be not so good. It is better to write a function. But then
Okay.
if you have just one statement, right, it will be better. But going for more than one statement or beyond two, list comprehension would not be a good for reading, right? It will lose the reading purpose.
Okay.
Right? Even the indentation will be lost. We have to maintain the right space, etc. That would be a problem. Then,
Okay.
but there is an approach. When you say two statements, I thought two conditions, but we have not seen that. We can have multiple conditions within the list comprehension. That is one thing probably I'll cover. But for multiple statements that you are trying to see in this, like let's say if I had rather than two or let's say this was about 5 or 6 statements, can we do that in list comprehension? Probably no. Let's not do that.
Okay.
It will erase the readability, right? So let's not do that.
Okay. Okay.
Very good. All right. So we'll see that. But your point raised another important aspect of writing multiple conditions. I'll try to bring an example in our next session.
Yeah.
Okay.
Thank you,
So
Jayant.
that was about it. So any questions on this? All right. So if there are no questions, then let's move ahead. The next topic that we will do is collections. Okay. Collections is something that we have to do, and then we'll do modules. And from there, we'll see where we have to go. Either we'll jump onto SQL or we'll try to do some other topics in Python. Probably we'll look at algorithms and classes, that is, or the OOPS concept that we have, or we'll move on to SQL. We'll see where do we go from modules, after modules, right? So, but the first thing that we'll do is collections. All right, so let me try to create a new file for our collections. Call is a Python file. And okay, this is not named correctly. So let me try to rename here. So this is a better way to put the file name here. So I'll call this as exe collections. Okay, so that it doesn't match the one that we'll be using now. So we had seen data structures already, the inbuilt data structures that are there in Python. So one aspect of using the inbuilt data structures is that They help us with a lot of operations that we have seen. And the previous set of exercises that we have done essentially are using data structures. But then Python also provides us a module that has these data structures in a different way, or something that they have built on top of the existing data structures. So this topic is about collections. So what we do with collections is essentially try to use the existing data structures in a different way, right? And what we'll look at is basically named tuple. Okay, this is something that we'll try to look at. Then we have counter. Then we have ordered date. And also we will try to look at one more collection, which is essentially deck. Okay, DEQUE. Okay, it is called as deck, right? There's a named tuple. So a named tuple is essentially in lowercase. That is what we'll try to use. So in order to use these, and there are others also, we have user deck, you have user string, etc. That is there in collections, but we'll try to focus on these collections as part of our sessions. And what are these is nothing but name tuple is an alternative for tuple, right? There is an alternative for tuple. Counter is similar to dictionary, but it has its own ways of using it. We'll see what it is. This is also kind of a dictionary. And this is basically a nice thing that is there that can be used as a stack as well as a queue, right? We can use it as a FIFO or a LIFO. FIFO example is first in, first out, last in, first out, right? We can use both of them here. We can either use a stack or a queue. The orderings is different, last in, first out, and first in, first out for queue and stack. So I would say like this, right? When we say stack and queue, this should be, this is how it should be, right? This is how it should be. Right, so a deck is deck stands for doubly ended queue, or double-ended queue, not doubly or doubly ended queue, right? I think the spelling is correct. Yeah, doubly ended queue, and that is what is a deck. But then if we get a chance, probably we'll look at some of the algorithms as we go further. We'll try to look at the sorting algorithms if we get a chance, but that depends on how well we are doing SQL. We'll also try to focus on sorting algorithms in Python. But these are some of the other data structures that we have in Python. These are already provided. So first thing is, how do we use them, right? So for that, we said these are basically present in what is called as a collections, right? So if we want to use them, we use this import statement and then call collections. Collections here is a module, right? Collections is a module. Collections is a module in Python. And this is a part of the standard library, okay? There's a module in Python standard library. It helps us with a lot of these objects or these data structures that are provided. The first thing that we'll look at is tuple. Now, how do we use this? This is one way of using it. So named tuple, not tuple, named tuple. So one way of using it is that we import this collections module, right? When we say module, it is basically having some kind of data structures. And when you hover it, right, especially like an IDE like Visual Studio Code, it presents us what it contains, right? This is basically a module. And a module will have different aspects, and what exactly is a module and what is a package is something that we will discuss when we get into modules and packages. But for now, understand collections is a module. Okay. And within collections, if we want to use named tuple, we can use it in this way. Just for understanding, I'm writing this. We can say something like this: collections dot named tuple. Okay, this is how we can import it, or we can use it, start using it. But then if we want to import named tuple also, we will do from and then specify collections. And what do we want to import? we want to import named tuple, right? So I do not want to specify the module name. Then I can do something like this and then start using named tuple. These are the two ways, and then we can remove this first line. Okay, so these are the two ways in which we can use it. Either specify the module name and the collection that we are using, we can use this. Or if we want to do it directly, let's say I do it directly, then I call this as named tuple. So this is how we can use the data structures that are there in the collections module. And what is the package, etc., probably we'll discuss as we go further. But right now, collections is a module that we have. And in this module, there are certain data structures that could be used. Okay, so now we have this. We know how to import them. So import collections and then use the first option. So if you want to use this, we go with this first option. Or if we want to use the second one, right? This is the second option. Importing the collection object itself by saying from collections import named tuple. So this is how we can use it. Now, what is a named tuple, right? Let's try to understand what is a named tuple. So what exactly is a named tuple? To begin our understanding, we can say named tuple is a tuple that is available in the collections module. Available in the collections module. Right? That is what we could say about named tuple. It is a tuple. We can say it is an alternative to tuple. Okay, it is a tuple that is present in the collection module. It is an alternative to tuple. That is something also we could say about tuple, right? And what can be done with this? We can create named fields. Named fields can be created with named tuple. Okay, so we can create named fields with the named tuple. That is what we can do. When we have these named fields, we can access the fields rather than I would not like to use we can here because we have not used this particular way of representing it. So I can say access, right? So I access field names. Or we could say fields. That is what we'll say, access fields using the names instead of index. If you recall, tuple, whenever we used it, we kind of access the values or the elements using the index 0, 1, 2, 3, 4, etc. But when we use name tuples, we can use index or we can use field names. That is what named tuple helps us to do it. Okay. So let's try to create our named tuple, right? So we have done this. So I'll remove this and I'll go with the second option for now. We can also use the first option, but then I'll try to comment these and then just import this statement. And by the way, the other statements that we have written are essentially comments. So these are not our programming statements. These are just comments to indicate our understanding of what we are doing with respect to this file, right? So that is what we do. And I'll say just play with named tuple. That is our named tuple. I'll call this and then we'll start doing something within this function. Okay, write pass. And because we are doing within this file, I'll write our main function. If underscore name equals underscore main, then I say pass. Right? And once we build upon our logic, we'll remove those pass statements. So now we have named tuple, right? So let's try to create our named tuple here. So I say st1 is equal to, that is the variable name that I use. Even before that, I have to do something like this. I say student, right? and then I create the name tuple. So this is what would name tuple be represented with. And then what is the name of the named tuple, right? I call this as student. Okay, I represent the same thing. So this is what would be used. And if you hover this, this says it returns as a named tuple or the type of what we are using. This is the type that we want to use, and that is what would be returned. So it is basically of type student, right? The name tuple is of type student. Okay, and then I want to provide some names to it. So what are the names? We can either use a list or a comma separated values within a string. Both are fine, right? Both are fine. We can use a list or a comma separated values to indicate what will be the names of the fields for that named tuple. Okay, so I provide names like this: name, age, department, and year. So these are the 4 fields that we'll use within the named tuple. So we have created a name tuple of type student. That is what we have done. Okay. Now we want to start constructing our named tuple. How do we do that? So I call our student1 as st1 is equals to student, right? This is our student. That is what we try to use here. It is of type student, and this is where it will be beginning to be used, right? So our named tuple can be of any type. It could be of student, it could be of lecturer, it could be of college, it could be of university. And then what are the fields it will have? And represent it with a variable. So it is of type student. As you hover over this variable, what does it say? It is of type student. So that is what we are trying to do here. The student will have 4 fields: name, age, department, and year. Where did we represent that? We represented that as comma separated values within quotes as string, right? This is one way of, or if we want to do this separately, we can have this list and list, and each one can be a field name. This is also the same, right? And then we can close this list. So the names of the fields are name, year, department, name, age, department, and year. These are the 4 fields. Either represent them via list or just put all of the field names separated by a comma and enclose them in quotes as string values. That's it, right? These are the 2 ways that we can do. Once we do this, the next thing is to provide the values for these field attributes that we have. We want to provide values. How do we provide? In student, we pass the first thing as the student name. I call the student name as Rajesh. And what is the age of the student? 19 years. And what is the department that he belongs to? He belongs to computer science. And what is the year that this particular student studies? So I call this second year. Okay, this is how we represent the student. Okay, so now quickly, let's try to print the type of this student. So I type this like this. Type of st1. The variable name is st1. That is what we have, the type of the student. And then print the student itself, st1. Let's see what would be the output of these 2 print statements. But we need to call this function from our main method. So I remove this particular pass and then call this. Right? So what do we see? From the main method, it is of type student. And what do we get? The student, what is the type of st1? It is student. And how does it represent? Student. And with the key value pairs or the name fields and the values. So we have name as Rajesh, age as 19, department as CSC, year as second year. This is how we get the student tuple printed out. Now, we want to get only the age. Let's say we want to only get the age of the student. So age of the student st1 is, and then I pass st1 dot age. We can access the age using the dot operator. This is our field that we have. The field can be called on this instantiated student. So st1 dot age, right? That is how we will be able to access the age. Okay, that is what we'll try to do here. st1 dot age, and we can print this value. So we get as 19. If we want name, do st1 dot name. If we want department, st1 dot department. If we want year, st1 dot year. Okay, so this is how we get the values. So age can be got in this fashion. Now, we have already seen unpacking. If you recall, we have seen how to unpack values. This is a tuple. We can unpack the values. How do we unpack the values? We have 4 variables. So I write 4 variables here: name, age, department, and year. Okay. And what should be unpacked? The tuple should be unpacked. I just pass st1 to it. It has 4 values. It will be passed to name, age, department, and year. Okay, how do we know that name is the value Rajesh, or the value of Rajesh is there in this name variable? We'll just print that out. Okay, we'll just print that out. Print name is name, or we will just use formatting and print all the values. Name is this, age is this, right? And then department is this, and then year is here, and then we format this. Sorry, it should not be here. I should place a bracket here, curly braces, and then we pass these values as comma separated so that we have the values in there. Why does this say an error? Oh, I see. This is okay. We are not using format, right? I should just pass them name, age. We are using the F formatting. If it was format, then it would have worked. Okay, and then remove this. Now this should work. All right. So name is name, year, age is yes. Okay. That is what. So we are unpacking this name tuple into 4 variables and then printing out these values. Right? We get the values in this fashion. So when I ran the program, we have the values that were unpacked and then printed as name, age, department, and year. So this is how we create a name tuple values, and then how do we get the or retrieve the values is in this fashion. There are multiple ways. On the created named tuple, we can use the dot operator, or we can unpack and get the values back as well. Is this fine? If it has multiple values and a lot of variables are there, probably then unpacking might not be needed. We just call them as st1 dot with the variable names. So let's also try to do that. So how do we do that? Just try to write a print function, print statement. And all that I'll do is I'll take this values again. Okay. I'll take this same thing, enclose them, and use a format. Instead of this, I'll use format, and then name will be passed here, and then age will be passed. Then department will be passed, and then year will be passed. Okay, this is what I'm trying to do here. Let me run this program again. And we get the same output. Okay, instead of using this formatting, I've used the format function on the string and then pass the values. And there are empty placeholders. Is this fine? So this is how I do the named tuple. Any questions on this? All right, so if there are no questions, let's see what to be done next. Okay, so next thing is we want to replace the value that is there in the let's say we want to change this Rajesh to Rajesh Khanna. Okay, let's say we want to replace the name. There is a function called as replace, and it is called as underscore replace. Okay, we have a function called as underscore replace on named tuple. What is our name tuple? It is st1, right? So st1 dot underscore replace name should be now Rajesh Khanna. Instead of Rajesh, we forgot the surname, we add it. Okay, and then we try to print this statement. Okay. Oh, we are not extracting it, right? So probably it will not come. So again, I have to do this. Okay, and then call this. Okay, now it should work. So new name or the modified name. Let's call this as modified name. Oh, we did that, right? Replace and still is showing Rajesh. So let me try to print this out once. Just give me a minute. I think I have to reassign to st1. Okay. Yes. So right. So now it prints out. So I reassign it and now it gets printed out. Then can use this and then I call this as modified name. And use these particular values again. Let me check the indentation. Indentation is fine. So there is no error. Now modified name is being passed. We have the age, department, name, and year. So let me try to run this again. Right now we get as Rajesh Khanna. Okay, so that is how we'll be able to modify the particular field that is there in the name tuple. So any questions on this, folks? So that is how we can replace. Fine. So this is how we can do it. Now let's try to see how do we access based on index. So it is the same thing. Access the values based on index. How do we access it? Right? We had given this as the variables, right? Instead of giving them as variables, what we have to do is, okay, I think I have to. So first thing is, let me try to change the steps once again, because there is one thing that will happen or go wrong is that I have to do this. Okay, this will make sure when we extract it, we get the st1 and then I can use st1 again. Okay, so based on index, let me try to print the values based on index. So I take the print statement again and I remove this indentation first so that this is fine and name is this thing. Okay, age is everything. All that I do is instead of name, age, these values, I'll pass st1 of 0 we already saw that named tuples can be accessed using index or named values. Okay, so that is what I do, and then run this. Make the statements different. I just use this. Okay, so now it's so department is 2. Why is it 2? Okay, I have to move st1. So st1 of 2. Okay, so we get the same values when done with the index based access. Okay, so this is how we'll be able to access the values based on indices or on the field names. Multiple ways of getting the values from the named tuple. So any questions still here? So if there are no questions, then we will see a quick thing. How do we create a tuple from a list? Let's say we have a list and we want to create a named tuple. Okay, we have a list of values and then we want to create a named tuple. So let me try to do this, and the internal function that we use is underscore make. Okay, this is what we use. So we pass list of values to the named tuple and then call the we put a list of values to the make function on the name tuple. Let me try to make function on the name tuple. We are using make, right, on the named tuple. And that is what we try to do here. And here, what we do is, let me try to create something like data. And then we have names here. So we have Kailash Kher. Or let me call this Kailash. And then we have the age, which is 18. And then we have the department, which is humanities. And the year is first year. Okay. So I call this as first year. So this is what we have. And then I try to create the named tuple. So I call this as st2. And then I use the student that we had created as a name tuple. And on this, I use the make function. So there is a make function that we have. And I pass this iterable value data to this. Okay. Fine. And then when I do print of new student value, I just try to print it st2. Okay, that is what I try to do. And let's run this. How do we run this? Already the function is called. So we are defining everything in our function play with name tuple. That is what we have done. And we have created this make function. So data is equals to this particular values. st2 is equals to student dot underscore make of data, print new student st2. Let's see if this gets printed out. Right, so we got this particular name tuple student with the field values name, age, department, and year. So make creates as a new name tuple by passing an iterable to it. Okay, so let's say we have this name tuple and we want to present it as a dictionary, right? All that we want to do is present it as a dictionary. So I call underscore as dict. That is what we have. Present the named tuple as dictionary. Okay, so that is what we want to do. All that I do is just call the name tuple. We have st2 and I call this as name tuple as dictionary. Okay. And then separate the comma and then call our as dict function. Okay. This gives us a named tuple as a dictionary. So a name tuple can be converted into a dictionary quickly. Right. So we get the value. As you see is the output, we get this dictionary with key value pairs. So name tuple can be converted into a dictionary. Fine. So till here, I guess things are okay. Any questions? If there are no questions, there is one last function that we can call upon for today? Any questions, folks? Okay, if there are no questions, then let's move ahead. There's one last function that we can have, which is called as underscore fields. We want to know what fields are there in a name table, right? That is what we want to know. What fields are there? So I say print named tuples, named tuple fields. And then fields, okay? That is what we have. You get name, age, department, and year. Those are the fields that are there. All right, so that is what we can do with name tuple. We have seen how to create a name tuple. And the basic fundamental thing is that it is an alternative to a tuple. Then we can have name fields to it. We can access the values using the field names or indices. Then we had seen how to replace a value. Then we have seen how to pass an iterable and then make a name tuple out of it. And we have seen how to convert a name tuple to a dictionary and also retrieve the field names from it. So these are the multiple operations that we can do on name tuples. Also, we can pass a dictionary to it also. That is also something that we can do. All right, so that's about name tuple. So probably I think this is a good time to stop for today. And then we'll get started with deck tomorrow and counter and finally order dict. And then we'll move on to modules and packages. All right, so any questions for now? All right, when will we do SQL? So we will try to complete Python first. So these are the other topics that I mentioned that we have. And if you'd like to know about object-oriented programming, we'll also complete that. But if you think we do not need it, then probably we'll go on to SQL. I leave it to the group if you would like to do it. And also I plan to do algorithms, some sorting algorithms in Python, implement selection sort, bubble sort, quick sort algorithms in Python. Probably we'll try to do that after SQL. Hope that is fine. And that is what we'll try to do as we go ahead. So once we complete modules and packages, I think we should begin with SQL. Okay, so that is the agenda for our next sessions. If there are no questions for today, then we'll call it a day. Thank you so much. Good night and see you tomorrow.